This week we're going to be talking about arithmetic sequences. We're going to be talking about how to find terms of an arithmetic sequence. We're also going to be talking about how to find an explicit and recursive formula for an arithmetic sequence. Recall that linear functions have a constant first difference. Notice also that when you graph the ordered pairs n, a sub n of an arithmetic sequence, the points lie on a straight line. Thus, you can think of an arithmetic sequence as a linear function with sequential natural numbers as its domain. So, for example, if I gave you something like, say I gave you a sequence like 2, 4, 6, 8, 10, ... Okay, this is called the first term. Okay, so n equals 1. This is the second term, the third term, the fourth term, the fifth term, so on and so forth. So when you're talking about an arithmetic sequence, basically it's like saying your x values are the n terms. So 1, 2, 3, 4, 5. Those are my terms. And then your numbers are your y values. So 2, 4, 6, 8, 10. Now, if they all differ by the same distance, okay, so the distance between each one of these is 2. This makes it an arithmetic sequence because they all have the same distance between the numbers. Now, if I graph this out, 1, 2 would be about here, 2, 4 would be about here, 3, 6 would be about here, 4, 8. They would all lie in a linear line, okay? So an arithmetic sequence is a sequence of numbers that always go up or down by the same value, and we call that the distance between the numbers. Each term of an arithmetic sequence is the sum of the previous term and the common difference. This gives us a recursive formula, a sub n equals a sub n minus 1 plus d. You also can develop an explicit rule for an arithmetic sequence. Okay, so those are two really important things for this week. We're going to be talking about an explicit formula and a recursive formula. Okay, we'll dive into that a little bit more in the next couple slides. Determine whether the sequence could be arithmetic. If so, find the common first difference. Okay, so if I'm looking at these functions, let me turn on my marker, but I'm going to make it a little bit thinner line so I can write better. Okay, so from -10 to -4, the distance between there is 6. -4 to 2 is 6. 2 to 8 it's 6. 8 to 14 is 6. So it's always going up by a positive 6. So my d value is 6, and yes, this is an arithmetic sequence. Now in this problem, it looks like it's always, well, it's going down. I go from -2 to -5, I'm going backwards 3 places. -5 to 11, that goes backwards 6 places. This is not an arithmetic sequence, and we won't be dealing with that tonight. We're only going to be dealing with arithmetic sequences. And now, how do you find a formula for an arithmetic sequence? Okay, so there's two different formulas that we're going to be learning tonight. The first one is an explicit formula. Okay, so this is explicit. And it's very easy to find an explicit formula. It's a sub n is equal to the first term plus, I always put the d in front, d n minus 1. Now, you can't leave the parentheses in your answers, and you'll see that on the assessment tonight. It'll say you can't leave the parentheses in your answer, and if you do, it won't be marked right. So let's say I gave you a sequence. Okay, so let's go 5, 8, that would be 11, 14, 17, ... Okay, so this is an arithmetic sequence. The d value, so in order to write this equation, you need the d value. What is the distance between each term? Looks like 3 here. What is a sub 1? Well, that means the first term in the sequence. Well, this is the first term in this particular sequence. It's 5. So now in order to write an equation, it would be a sub n is equal to 5 plus 3 n minus 1. Now, I can't leave parentheses, so I'm going to multiply through here. So that would give me 3n minus 3. So I still have that 5 there. So my formula is going to be 3n plus 2, because I just did the 5 minus 3, which gives me 2. So a sub n is equal to 3n plus 2. Now, do I know that it works? Well, guess what? I know what, let's say 1, 2, 3, 4. The fifth term is 17. So if I plug 5 in here, I should get 17. 3 times 5 is 15, plus 2 is 17. So a sub 5 is equal to 17. And that's what this little subscript means. So if I said, what is a sub 100? That means, what is the 100th term? Just put 100 in here. 3 times 100 is 300 plus 2, so that would be 302. So I should be able, once I come up with my explicit formula, I should be able to find any term in that sequence. Okay. So here it says, find the nth term of the arithmetic sequence. And when it says find the nth term, what it's really asking for is, what is the equation? Okay. So what is a sub n? What is the equation for this thing? And then it wants me to find the 12th term. So once I find that, it wants me to find the 12th term. Okay. So now what's my d value? Uh-oh, this one's a little tricky because it's going backwards, isn't it? 20 to 14 to 8 to 2. So it looks like my d value is -6. Oops, that doesn't work, does it? 8, 2, this must be -4 here, okay? Because if it was +4, it just wouldn't work. That must be it. There must be a missing negative sign there. So my d value in this problem is -6. My a sub 1 is equal to 20. So if I want to write my equation, remember it's a sub 1 plus d n minus 1. Okay, so that's going to give me 20 plus -6 n minus 1. So that's going to be 20 plus -6n plus 6. So -6n plus 26. That's my explicit formula. -6n plus 26. Does it work? Well, just pick any one of the terms that you know. I know the third term is 8. So if I put 3 in here, I should get 8. -6 times 3 plus 26. -6 times 3 is 18 plus 26. Oop, that'd be -18, which is 8. Huh, it does work. And then it wants me to find the 12th term. Just plug 12 in here, and you would get the 12th term. This is called an explicit formula. Find the 11th term of the arithmetic sequence. Again, now it looks like it's going backwards again. It looks like this time the d value is -2. And it looks like my a sub 1 is equal to -3. So I've got a sub n is equal to -3 plus -2 n minus 1. I'm going to multiply through here. So -3 plus -2n plus 2. So -2n minus 1. That's my explicit formula. If I want the 11th term, plug 11 in here. -2 times 11 is -22. Minus 1 is -23. So the 11th term, so a sub 11 should be -23. Okay, now we could actually just keep going out. You know, this is the first term, second term, third term, fourth term, fifth, sixth, seventh, eighth, ninth, 10th, 11th. Does work out. But we definitely want you to be able to write an explicit formula there. Because arithmetic sequences have a common difference, you can use any two terms to find the difference. So for example, if they gave me a sub 2 is equal to -131 and a sub 3 is equal to -121, I should be able to figure out what the d value is, right? So the d value, and it asked me to find the 11th term of this arithmetic sequence. Well, a little bit of thinking here. I would write down, a sub 1, a sub 2, a sub 3. Well, I know what a sub 2 is. It's -133. I know what a sub 3 is. It's -121. So if I just subtract those, I should get my d value, right? So 133 minus 121 is going to be 12. So if I wanted to find my ace of 1 value, which I do need in order, so ace of, or my D value is 12. So if I wanted to find my ace of 1 value, I just subtract off 12, so I get negative 145. So now I could write an equation using that information. So since we know that an explicit formula or an arithmetic sequence, all the values are the same distance apart. If they gave you two values, you should be able to figure out what the distance is between those, and then you can write an equation and stuff like that. Now, the other type of, well, we're not doing series today. The other type of equation that we're going to be dealing with, that's not right. Well, that goes into next week. Sorry about that, guys. So let's talk about explicit formulas. No, we just talked about explicit. We're going to talk about recursive formulas now. Okay. So let's go back to these types of problems here. We know how to write an explicit formula. Explicit formula is easy. Now, if I want to write a recursive formula, okay, so that's a totally different type of formula. So I'll do both of them for this one. So recursive. So a recursive formula just uses the value before to get to the next term. So for example, when you write a recursive formula, it's going to look like this again, but you are going to find out that it's going to look something like ace of n is equal to, and then ace of n plus 1 plus your D value. Okay, so and when you think about terms, let's just take a simple one. Let's go 4, 7, 10, 13, 16. Okay, so this is ace of 1, this is ace of 2, this is ace of 3, this is ace of 4, this is ace of 5. So how do you get to the next term? You're just adding 3, right? So if I wanted to write an equation, I could write ace of 2 is equal to ace of 1 plus 3. If I wanted to know what ace of 3 is, I could just say, well, that's ace of 2 plus 3. I'm always adding 3 to get to the next term, right? So I just add 3 to get to this next one. But that would be awfully hard to write an equation like that. So what we do is we just say our recursive formula is just ace of n plus 1 plus D. I'm sorry, it's going to be n minus 1. So ace of n is going to equal ace of n minus 1 plus D. So if I wanted to find ace of 3, so let's use this formula. So if I want to find ace of 3, I put 3 in here, so that would give me ace of 3 minus 1, which would be ace of 2 plus D. So ace of 2 here is 7. 7 plus 3 is 10. So it's always going to look like this. It's always going to be ace of n is equal to ace of n minus 1, that's a subscript, plus D. Okay, that's how we find a recursive formula. Now, the one thing that's not nice about recursive formulas, I couldn't say, okay, write a recursive formula and then find the 100th term. You can't do that. Recursive formulas only give you term by term. So if I wanted to find the third term, I'd have to know what the second term is, because then I would add on the D value. In order to write a recursive formula, you always have to tell what the first term is. So you always have to say ace of 1 is equal to, in this problem, it was 4. And then my formula is this. Okay, so let's do a complete problem. I'm just going to clear this out. Okay, so let's say I gave you, I don't have any blank sheet, so just don't look at this stuff over here. So let's say I gave you the, let's say I have 10, 15, 20, 25, ... Okay, first thing, and I ask you to write a recursive formula. Okay, first thing you want to do is you always want to say what the first term is. Ace of 1 is equal to 10. And then my formula is going to be ace of n is equal to ace of n minus 1 plus the D value. Well, in this case, the D value is 5. So this is my recursive formula right there. I know what the first term is, it's 10, and then it's telling me that I have to add 5 onto the, so if I was going to write my equation out, it would be 10, and then I have to add 5 onto that term. That would give me 15, and then I have to add 5 onto this term to get to the next term. Then I have to add 5 onto this one to get to the next term. I have to add 5 on. So do you see why if I asked you to find the 100th term using a recursive formula, you'd have to write out every single problem or every single number up to 100, which is really kind of crazy. So a recursive formula for an arithmetic sequence is fairly easy to find. It's not really nice to use because you can't find the 100th term. That's why 95% of the time we ask students to write explicit formulas, not recursive. Okay, but there is a difference between them. All right, hopefully we'll see you guys on Monday for the main lesson. We'll go through all the practice problems for the week. You guys have a great week. Bye.